Exactly. That's what you're Yeah.
Good morning, everybody. I want to give you as much practice time as possible. Just in case you're away yesterday, just a reminder, make sure to see whatever calendar app you use or in the actual physical diary. The test is this time next week, so 7 days to test. And you will have at least Monday and probably part of Thursday's revision lessons leading up to that. Okay, okie dokie. Charlie, on the printer upstairs is a printout. Could you go grab it for me, please? Is a math study? Thank you. So yesterday's lesson, I introduced you towards the end of that lesson to rationalising the denominator. I just want to go through a couple of examples to make sure you're right with it. If you weren't here yesterday, I know this is going to sound a little bit confusing. We went through the rationale yesterday. I just want to focus on the actual process today. So these are just examples. Oh, got the black, it's a bit easy to see. So it's called rationalising the denominator. Speaking of denominators, don't forget that there's an open sort of invitation for you to just ask me if you feel like you need assistance with fraction knowledge. Don't be afraid to ask. It's just everyone has gaps in their knowledge, and the sooner you close those gaps, the better it is for doing harder maths, I suppose. Yeah.
Just as a question, can you rationalise the numerator, or just the same?
There's no need to, I think. You can't rationalise everything. Now, so if you had the square root of 2 over 3, for example, if you try to rationalise the numerator, you'd end up with an irrational denominator, right? So you can't fully rationalise it, because otherwise that's like saying root 2 on 3 is somehow a rational number. So you can't rationalise all of it, you can only rationalise part of it. And for reasons I went through yesterday, it's the bottom number that's better to be rational. Yeah, okay. So I want to go through a few examples. And again, I know there were a few people away yesterday. So what I'm talking about is just choose a really simple one to start with. If I start with, say, 2 over the square root of 2, rationalising the denominator means that there's a whole number as the denominator. At the moment, root 2 is the denominator, and that is an irrational number. So what we do is we use equivalent fractions to multiply top and bottom by that irrational number. And the result is 2 root 2 on top, and root 2 times root 2. And the thing you have to get used to, I have said this a bunch of times, but I know it hasn't quite sunk in for everyone yet. If you multiply a square root number by the same square root number, it's just the number left over. You can do it longhand to prove that for any number. Okay, so 2 to the half times 2 to the half is 2 to the 1, which is just 2. So it's always the case. So we can just do that. So weirdly, I hope you can see that there's a cancel down operation there. Weirdly, I think it's weird anyway, no, it's just me. That's just equal to the square root of 2. So 2 divided by root 2 is the same as root 2. You can test that on your calculator. Yeah.
How did you get the root 2 over root 2?
Okay, so this is standard equivalent fraction logic. If I have a fraction and I multiply the top and bottom of that fraction by the same number, then the result is an equivalent fraction. So in whole number land, we're used to sort of like saying 1/3 is the same as, say, 2/6, right? Because we multiply top and bottom by 2.
So is rationalising pretty much just
Rationalising
changing it to make it easier?
Rationalising is using equivalent fractions to make the bottom number a whole number instead of a third. Yesterday I explained why. I won't go through it again because it just takes a bit too much time to really pull it out. And even when I did it yesterday, people still didn't quite click. So I'm just trying to focus on process rather than anything else. I'm happy to have one-on-one discussions. I just don't want to keep on going with long explanations about it. Example 2, if I had 3 on 2 root 2, then I don't have to multiply it by 2 root 2 on 2 root 2, I just multiply it by the root 2 bit. If you don't like that, if you prefer just to write root 2 times root 2, that's okay as well. It's whatever you do normally for equivalent fractions, I tend to write it like that because it reinforces that all I'm doing is multiplying by 1. So that will be 3 root 2 over 2 times 2, which is equal to 3 root 2 on 4.
Can you simplify any further from that?
The only thing you can simplify is the whole number part, and because 3 and 4 has no common factor other than 1, it's as simple as you can get. Remember, big mass takes place here. That 2 belongs to the root, so you can't cancel down the 2 and the 4, if that's what you're asking, because it's underneath the root sign. If you forget that, maybe putting a little bar over it might help you remember. So I can't divide 2 and 4 together because the I in big mass indices takes precedence. Yep.
What symbol is the first equation sign when the 2 2's are?
Yeah.
No, the next one.
That one?
On the far right.
That one?
No, the 2.
On the far right, sorry.
Far right.
Yeah? Shall I come to you?
The 2 and the 2. In between the 2 and the 2.
Times.
Oh, I can't see it.
How's that?
Now I see it. You want more?
Plenty of us space up the front, Henry. Okay, any questions about that? So you only have to multiply top and bottom by the root part. Did you get that, Charlie? Did you get the stick? I'm going to go for example. Oh, maybe I'll keep it zoomed out and have it right a bit bigger. For example 3, it's going to take me a little while to sort of explain this, but it's the last example before you get going. Example 3. 2 on root 2 plus root 3. Now the problem with this, what do you think I should do? You won't get it. He says challengingly. You won't get it. But what do you think I should do to rationalise the denominator? We'll try a few different scenarios. I bet you can't get it. Go, Raph. Raph had that look on his face which was challenge accepted. Go on.
Is it possible that you can just for now pretend that the root 3 is not there and then rationalise that and then add the root 3 and then see if I can.
No, we can't pretend things are not there in mathematics. I love your thinking. It's just not there. I'm just not going to deal with it. And then put it in later. No, we need to be rational with our mathematics, not emotional.
Is that
Yeah, James. Give me a suggestion.
is that times or plus?
Plus.
Oh,
Oh man.
And I'm not.
Honestly, it's a picky brigade around here.
That looks like a multiple.
Yeah, whereas like
Is that better?
Yeah, that's a multiple.
It's not just you.
Times it by. I saw that one.
So I'm not even going to try to pretend it doesn't exist. That's not mathematical. Give me something else I can try. Leo.
With the other ones,
Girls, why don't the boys dominate the room? But go, Leo.
with the other ones, you've done things like times them by the thing on the bottom.
Yeah.
Do we just do that again and do square root 2 plus square root 3 liney thing and then
Tom bottom, should we try that?
yeah?
Okay, that's the first concrete example I've got of what to do. So, we're going to times it by root 2 on plus root 3, and then times the top by root 2 plus root 3. These are all plus signs, okay? Alrighty, so let's do that. So on the top, remember we're multiplying the whole of the two tops there. So it's 2 multiplied by root 2 plus root 3. And on the bottom, I've got root 2 plus root 3 multiplied by root 2 plus root 3. Now this is absolutely equivalent excuse me. Maybe put your hand. I think maybe put your hand up. It's easier for me to manage them. These are absolutely equivalent fractions. This is absolutely the same as this, but will it work? Charlie.
Can't you, on the top example where you've got 2 over root 2 and then you times by root 2, you change You said root 2 times root 2 is 2. So how come you can't just make the bottom 2 plus 3? Because root 2.
What's what we're going to try and do, isn't it?
Yeah.
You can't just magically do it. You have to apply.
Yeah.
You have to apply operations consistently, right? You can't just pick bits and just do like pretend, or just pick bits, which is effectively the same as pretending. Ignore the bit, move this bit. You can't just do that. For example, I can't just go. Oh no, let me just take this through first, okay? I promise I'll come back and respond to your answer. So the top is going to be 2 root 2. This is just an expansion plus 2 root 3. That's okay. I don't care if there are irrationals down the bottom, up the top. It's just irrational down the bottom I worry about. I wouldn't be writing this down if I were you. Let's have a look at the bottom though. The bottom is a perfect square, yeah? It's a perfect square. I've multiplied 2 things added together by those same 2 things added together. So it's a plus b all squared. Okay, so that means I'm going to square the first one. Oh, this is looking good. The square of a square root is just the number inside. And I'm going to square the second one, which is great.
This is where.
But we're in trouble because when we expand a perfect square, we've got twice the 2 numbers in the middle. So we end up with 2 root 2 plus 2 root 3 all over 2 plus 2 root 6 plus 3. Now I can simplify that to 5 plus 2 root 6, but we've still got an irrational part to our denominator. Okay? So that doesn't work. Just to answer Charlie's question a little bit more specifically, sorry Hannah, if I say this to kids all the time and they never listen to me, but I'll try again with this class because you do actually listen to me sometimes. Often when you're trying to make sense of something in an unusual world like SERVs, take it to the world you're familiar with and try it out there. Because if the logic doesn't work with regular numbers, it doesn't work with any number. Okay, so for example, if I had, let me see now, 2/3, I could write that as 2 over 1 plus 3, 1 plus 2. Right? Now you can see straight up there are a bunch of things I cannot do over addition because it just doesn't make sense. I cannot cancel out the 2's here. Because if I did, that would be like saying 2/3 is the same as 1 over 2. 2/3 is the same as a half. Okay? We know that's not true. We cannot cancel down over a part of an addition. And for similar logic, we cannot do the same thing with multiplication. So I can't, for example, I have to choose I hope this example works, but sometimes it works by mistake. I can't say, well, I'm going to multiply this by 1. Oh, I'm going to make it different. I'll make it 2/5. I can't, for example, multiply this bit by 3 and multiply this bit by 2 and multiply this bit by 6. I can't do that. Right? I end up with getting 12 over 9 plus 4, which is 12 13. And I think we can all agree that 12 13s are absolutely not the same as 2/5. Okay? So, without going into too much detail, if it's not making sense in usual number world, it won't work in random number world like algebra or SERVs or whatever else. Is that, I know it's not a massively clear answer, Charlie, but is that a glimpse into truth there?
Yeah.
Okay, cool. Like that, a glimpse into truth. Oh, I might want to evolve with me. Okay. I'll just leave it at that for that one. So that's not a good, it's not a good start, but it's actually closer to the truth than what I thought we might do, which is start off by multiplying everything through by root 2 and see what happens, and then multiply it all through by root 3 and see what happens, multiply it all through by root 6 and see what happens. So these are all kind of instances that we could try, none of which will work. I'll just give you the hot tip now, they won't work. So Leo was pretty close because he's multiplied by something in an attempt to get rid of the root 2 and the root 3, something more complicated. like root 2 plus root 3. That didn't work. Now, let me give you just a minute to talk in your little table groups there, so I don't need to go too far. Although maybe Sam, maybe turn around and talk to Chris and then I'll just make it pairs more or less there. Leo was on the right track, but perfect square was not right. Do we have any technique which will leave us with just 2 squares instead of 3 terms, just 2 squares? Talk to the person next to you. Do we have any technique, expansion or factorisation, that will allow us to leave us with 2 squares?
What are the other ones called?
So we've got a sum of 2 squares there, 2 square roots, right? We can see that if we got to the point of squaring root 2 or squaring root 3, we can get rid of this. So we need some sort of operation, or some sort of technique to go from 2 numbers to the square of 2 numbers. Don't worry about that, it's exactly kind of like this, not how we get there.
We need 2 numbers.
If we finish off with the square root of 2 squared, that will get rid of the square root. Yeah? If we finished off with the square root of 2 squared and the square root of 3 squared, the act of squaring those two numbers would remove the square root sign.
Because
Square root. Does that make sense? I'm not saying how, I'm just saying because the idea is.
I love the evidence everywhere in that book.
Go to your page when you want something. There are techniques in there that will allow you to sort of back to what else? Think about those other 2 possibilities. So the intention makes sense. So what else?
Yeah. I just want to restart my body because they're all like kind of.
What factor would you take? No, that doesn't work. I haven't even looked at that.
Oh my god.
Square of root 2.
I said no.
It is bad. We don't know.
Root 2 2 squared.
And just because of time, I'll break it over.
2 squared. 2
That's what I'm saying. You can never cancel that over. You should might be
It's like 16.
You can
You got an idea?
Oh, yeah.
Do you have an idea?
I don't have the jumper yet.
I don't have the anything about it. Stuff like that.
Is it gonna be a negative on the bottom?
Oh, you do.
So root 2. What number times?
No, it's more related to the algebraic techniques that you have on.
Okay. Wait, so if we just
So refocusing to the front, please.
how do I get that up on my computer? So I can see it better.
You put in the thing up the top.
Web browser.
Yeah, cheers. No, it's just easier on my eyes. It's just easier on my eyes.
I agree. It also means you can take screenshots when you want to as well.
Wait.
Anyone who prefers to see it right in front of them instead of all the way over here, anyone's welcome to. If you favourite that or bookmark that, you can look at it on your screen whenever I use this.
Is that one gonna work for every single?
Yeah, all the time.
All the time.
Yeah, every time I use this. And the other bonus is that if you're really bored in a lesson and you want to see what I'm doing in some other lesson, you can just fire it up and watch this random stuff appear on the screen.
It's the same one.
Yes, people do that. It is the same for every lesson, yeah. Okay, so I'm very keen for you to get to practice, and we're already 20 minutes in, so 25 minutes in. So I've wandered around the class. Some people weren't too sure where to start. Some people managed to crack the code a little bit. So when I said what techniques can you use, I was talking about those expansion factorizing techniques. So we've got perfect square, which we've just said it doesn't work. We've also got highest common factor, but the only common factor there is 1, and multiplying both things by root 2, like introducing a new common factor, doesn't seem to make a difference. That's what I was saying before. If I multiply it by root 2, then this will become root 6, which is still irrational. If I multiplied everything by root 3, this would be root 6, which would still be irrational. If I multiply by root 6, then that'll be root 12 plus root 18. There's nothing really that I can do, because whatever I multiply top and bottom by has to affect the whole of the top and the whole of the bottom. Like we were saying before with Charlie and Raph, we can't just ignore part of it and multiply the other part. So those things aren't working. So that leaves us with very few options really. We can try some sort of monic trinomial, but the problem with that is that the trick is in the title, right? You end up with a trinomial, a 3-part, and one of those parts will always be irrational. So that doesn't work. But there is one which sort of gives it away in the title, and that is difference of 2 squares. So we end up with 2 squares, not 3 parts, but just 2 parts. And it's just a square of each part. So we've got this bit. So if we can use difference of 2 squares, we're cooking with gas. So what we do instead is we take the root 2 plus root 3, and we're going to multiply it by root 2 minus root 3. And to keep it equivalent, I do the same thing on top. Now this gives us 2 outside of root 2 minus root 3 on top, and it gives us root 2 plus root 3, root 2 minus root 3 on bottom, and the bottom there is a difference of 2 squares. So on the top, I'll have 2 root 2 minus 2 root 3, and on the bottom, I'll have root 2 squared minus root 3 squared. Difference of 2 squares. And just to keep it on the one screen, I'll just put it over here. And that's equal to 2 root 2 minus 2 root 3 all over 2 minus 3. Okay? You can think of square and square root as all opposite operations. They undo each other. And that leaves me with 2 root 2 minus, minus 2 root 3 all over negative 1, which is a bit ugly to leave it as that, but basically, is it okay if I'll just explain it and I hope it makes sense. If it doesn't, just let me know. Basically, if I've got divided by negative 1, it's basically saying this whole thing is negative. So it's equal to negative 2 root 2 minus 2 root 3. That bracket shouldn't be there, that second bracket shouldn't be there. And then finally, I mean, I wouldn't really do this. I just go straight to the final line at this point, but I'm just doing it just so it's really clear to you what I'm doing. That'd be negative 2 root 2 plus 2 root 3. And I won't put this final line in, but I'd actually then switch those two. Oh, you can't see it. Hang on. There we go. So 2 root 3 minus 2 root 2 would be the final answer. I won't put that in because that's what I've got there is fair enough. So the important thing is that you just multiply top and bottom by switching the signs around. So if it was root 2 minus root 3, then you multiply by root 2 plus root 3. So you want to get it so you've got those opposite operations in the middle so they can then use dots. Just pause there and ask if there are any questions. Yeah.
Will there be this sort of questions on the test?
Absolutely.
It's just what steps. That's what I'm thinking.
I think what you're seeing here is, and you said it, but there are gasps around the room when I said yes, it'll be on the test, as if this is really massively hard. It's not. It's not. What you're struggling with is unfamiliarity. You haven't seen it before. We are not in grade 8 maths. You are in 9 maths extended. You should expect to see multiple step stuff to get an answer. Otherwise, get out of maths extended because you just want easy street for the rest of the year and stick in grade 9 maths. I mean it. You're meant to be extended in this class. You're meant to be here because you're prepared to engage with more complex mathematics. You all deserve to be here. But you cannot have the attitude of, but I'm a good math student, I should just be able to do it in 2 lines. I've said this consistently from day one. That is not true. A good mathematician is someone who perseveres at mathematical tasks. And that usually means multiple steps. When it comes down to it, there are just a couple of critical steps. The most key step for understanding is this one here. What do I multiply top and bottom by? This one here is an explanation step. You don't need it. You can go from here to here if you feel comfortable. Even to here if you feel comfortable. It does not have to be 5 steps, but of course, when I'm explaining it to a class, I need to make it 5 steps long. Okay, because you need to see the intermediary thinking steps. You don't always have to simplify your fraction at the end, so be mindful that the steps after that last red star may not even be necessary. So you need to look for it. I'm going to go through one more example and attempt to show you how straightforward it can be once you have practiced it. The more time I spend here, I know I get the irony, the less time you have to practice. Root 5 minus root 3, and I'll say it's just 7 over. Okay, first step, identify what you need to multiply by top and bottom. Who's feeling brave enough to say, I think I know? Leo, go.
Would it be square root of 5 plus?
Right, opposite operation?
Opposite operations.
Yep. And it's always the same top and
Yeah.
bottom, otherwise it's not. Otherwise it wouldn't be equivalent fractions. So it's just same thing, top and bottom. Then I'll do it with arrows this time, but this is just me thinking. This is me just writing out my thinking. 7 times root 5, and then 7 times root 3. So I end up with 7 root 5 plus 7 root 3. all over. This is dots. So I'm going to go straight to my dots pattern, which is root 5 all squared minus root 3 all squared. So that's 7 root 5 plus 7 root 3. In fact, I'll just do it in the shortest possible way now. I'm going to do the rest in my head. Root 5 squared is 5. Root 3 squared is 3. 5 minus 3 is 2. Done. So 3 thinking parts. Number 1, what do I multiply top and bottom by? Number 2, what's the result of it? Number 3, clean up. Don't worry, I'll go back to this page in a second. This is me explaining everything. This is me explaining everything. Sorry, I should have put the red star there. The first one. This is me explaining everything. This may also be you to start with because you're trying to make sense of it. At the end, that's what you'll be doing. Okay, can you get your, James. Come to you? Okay, after everyone's done work. Can you please take out your worksheet that I provided for you? Monday, last week, whatever it was.
The one that is like what's paper.
Yeah.
That was like.
This thing?
Can't remember, okay. Yeah, that's it.
Staple one?
Yeah, this one? You still need this? Right, I can print out a couple more copies in a second. It'll take a while to print out this all.
No.
Anyone else need this that I don't have for some reason? This is from last week.
Are we trying to sort of rationalise the denominator again?
Yeah, so, but I just want to give you a bit of guidance, Charlie, if that's okay. So, turn over to exercise set 32, please. So last week, we dealt with addition, subtraction, multiplication and division, as well as basic ideas of surds. This week, we're going to start by looking at rationalising the denominator. This is what we've been doing last lesson and this lesson on the book with board work. Really important thinking work. Now, you can do, what I think would be worthwhile doing is one of two things. Either just work your way down the left-hand side, so all the odd numbers. That'll give you a small set of those simpler ones, and then a small set of those harder ones. Or, if you feel like exercise set 32 is a bit too straightforward for you, you look at it and go, yeah, nah, I think I would be okay with that. You could do all of exercise set 33. In other words, practice more the harder ones. Does that make sense? So you can either do some easier, I'm not saying easier or easier followed by harder, or you can just do all of the hard ones. Whatever makes sense to you. Okay, I'll go print out a few extra copies and I'll come around and help people.
Would you mind just putting it so it's like...
I'll be back to that. I just need to stop the video recording, which will be up on Google Classroom a bit later.